Okay, this video is about motion problems, and specifically it's going to be about round trip motion problems, okay? And you remember that motion problems usually involve the equation distance is equal to rate times time. Okay, so let's take a look at this particular problem. Now, according to this, Senna bikes to school every morning, and since she goes slightly uphill, she pedals at a rate of 15 miles per hour. Now, when she goes home in the afternoon, she can achieve a speed of 20 miles per hour because she's going downhill. Now, assuming that she goes the same route in the morning and in the afternoon after school, and assume also that the entire trip back and forth, if you added both of them together, takes 5.25 hours. It's a long ways, huh? Calculate the distance that she lives from school. Now, that seems like a rather difficult problem, but if we start taking this apart, we realize that there's two equations that we have to create here, okay? And one of the equations that we're going to create is the equation distance is equal to rate times time, but it's the equation when she goes to school. Let me show you how this works. I'm just going to box all these off. So this would be the distance, this would be the rate, and these would be the time. So this is going to school, and this is coming and returning, okay? Returning home after school. We're asked to calculate the distance that she lives. Since she's a round trip, this distance is going to equal the return distance, okay? So let's just do that. Now, what's the rate that she has going to school? Well, according to our information, she's going 15 miles per hour. Going home, it's 20 miles per hour. Now, we don't know how long it's taking her to go to school, so we'll just call that time sub 1, okay? And returning, we'll call that time sub 2. Now, the only thing that we do know about these two times is that if we add them together, we'll get 5.25 hours. All right, so let's just do that. So that T1 plus T sub 2, which means they're two different variables. They can't be the same, right? Is equal to 5.25 hours. And if we were to, let's just say, try to get one variable only, so let's just pretend that we say T sub 2. Let's subtract T sub 1 from both sides. There we go. That way, wherever we see T sub 2, we can just substitute in 5.25 minus T sub 1. Sorry about that. Let me just change that real quickly. There we go. That way we'll only have one variable, okay? So let's put in 5.25 minus T sub 1. All right. So now we only have one variable in this equation. Now, we do know that the distance going is going to be equal to the distance back, but we also know that the distance is equal to 15 times T sub 1. So 15 times T sub 1, and that's going, all right? We'll call that going. And that should be equal to the distance returning. Distance returning would be 20 times, not T sub 2, but what we substituted, 5.25 minus T sub 1. Now you see why we actually went ahead and did this, because now we only have one variable to solve for, okay? So let's go ahead and start solving this. Let's use our Roman numerals. So 15 times T sub 1 should be equal to 20 times 5.25, which is 105, minus 20 T sub 1. Add 20 T sub 1 to both sides, and you'll get step 3, 35 T sub 1 is equal to 105. Let's divide both sides by 35, and you're going to get T sub 1 is equal to 3. Now, we can go back in and plug that in. So basically, we know that it took Senna 3 hours to get to school in the morning, which is really a long way, and only 2.75 hours. No, 1.75 hours to get back in the afternoon. But that's not the question, right? The question is, calculate the distance that she lives from school. So let's check this. 15 times 3 hours is 45 miles. All right, now let's plug it into this last one. 20 times 5.25 minus 3. Let's see if that's equal to 40. So that'd be 20 times, that would be what, 2.25? And when you multiply 2.25 times 20, sure enough, you get 45 miles. Okay? So again, whenever you see these kind of problems, a round trip problem, make sure that you break it up into two equations. Distance is equal to rate times time. Find out whether they're equal, and then read the information to see if you can create any other relationships, like, T sub 1 and T sub 2 is equal to 5.25 from the information in the problem. Okay, I hope that was helpful.